Hello everyone, I am Nimal Dinesh. I am going to present you the internship topic which I have done the project in the name of microwave oven. Let's dive into the topic. Okay, in the topic I have learned about C modules where the section which entirely focus on software modules written in C where you can see the setting the timers, starting the and stopping the oven. You can know like handling the input from the peripherals and in the embedded system overview you can see like overall and the embedded system architecture you can know about the microwave oven. It would cover the processor, memory, input and output interfaces, and this component interact to make the microwave function properly. And another ways in the project peripherals have done, you can see like LEDs in your microwave system might can be used for system indication, where matrix keypad, the keypad is used for user input. And also CLCD, which is defined as character LCD. This LCD will display important information to the user such as current time, eating status, and also you can see power level and error messages. And another one which I have covered is times and interrupts. You can ask like why we can use the times and interrupts. It is used specifically for cooking time and other timed events such as turning the microwave oven on or off at the specific intervals. In the meantime, you can like mostly in the Indian time, many people forgot about the time about the cooking. You can use times and interrupts where it's to use your inputs or handled efficiently without any delays. In the project implementation section, I will detailed about like I have implemented the various functionalities and features. It could include coding examples, block diagrams, and step-by-step descriptions. In this internship, we have worked in a specific field like assignments and live interactions, which I have done many assignments in the intersections. Also, weekly tests were conducted and the evaluation was done in a good manner. And the third one is now you can see like project implementation. It's like a good like you can see like it's a pleasure time to spend with the emerging technologies. And you can see like in the introduction of the C, I can see like C is like high level programming languages used for system programming and low level hardware interactions. In embedded system, C provides direct hardware access, efficient memory usage, and also you can see and in the meantime you can compare with any languages, but you can embedded C is the it's a type of language which outstands in the embedded system productions. It is useful and also its efficiency is unmatchable. In the data types you can see integer, float, string, anything, and extra. You can see like types of the data types and incisors, and also print and scan of functions also written in the project sections. The conditional statements, if block, and you can see if block is mainly used for in the condition which have the condition is applied to the problems. And also in the switch blocks you can gather many conditions and you can compare with, okay, I need to compare with temperature in the Celsius of 70 or 100 or 50 or default value. You can compare with that. And also you can it's also almost safe for the while and do while, and you can furtherly deep into the for loop, which is mostly used in the world. And also operators in C, you can see like operators in C are defined in the like you can see like symbols where plus, minus, and logical operators like and or, and you can see like bitwise operators. These can like the data you can compare the originality and also the maximum and minimum level of the input which is given by the user, which is nothing but our client. The arithmetic operator can be used for addition or subtraction or modulo or division, and logical operator obviously for using like logical propagations. And relation operator is used to compare the both inputs which is given by the user. And also assignment operator is used to assign the some type of things, and bits wait office of operator is used to move the things, and also it can be able to perform the operations. uh, Next we can see about the array and pointers, where an array in a C collection of elements where it is can be contiguous memory location. You can see like it allows low EC and also manipulation of multiple values using a single variable and index. You can see like character is nothing but in a it is given under the single quotation mark, where it can be stored in various numbers in like array. You can see like if we give a specific size of the array inside the, you can see the square brackets inside, you can give any numbers. Like in this case I have given 5, where you can store along 5 types of like characters. And you can see in the pointer sections you can like character stores str, which nothing means by like a string is like a array. Like you can see string is variable, but it is mentioning the pointer, which in the third line you can see about string str equal to, and a it is meaning about the and meanings like it is like address, it means like it can point out the address of the str variable. You can print off the percentage d for the str, and you can also percentage like you can print the address of the str. And strings and macros. String is like collection of characters with a null character, which is used in the end, used to store and manipulate the text. A macro in embedded system is a preprocessor directive, like that can be able to replace the code before any kind of compilation or any like languages. Optimizing performance or reducing memory usage can be the main point of the macros. Like you can definitely it is said to be a setter file, like you can say main.h or conio or sddio. It kind of like a macros, it is used in the like head of the program. And you can see like in the intro of embedded system is can be sold by like a simple combination of hardware and software. An embedded system is a specialized computing system designed to perform dedicated functions within a larger system, often with real-time constraints. It combines hardware and software, typically using microcontrollers or microprocessors. Application of embedded system can be said to be as ABS, washing machine, air conditioner, refrigerator, and television. And peripherals can be told to be like it is a connection unit where it is used in mainly keypads, mode selection, and power control. Level triggering response to a constant signal state remaining activity for like stays high or low. A matrix keypad is a peripheral used in embedded system for user input, consisting of rows and columns forming a grid of switches. It reduces the number of GPIO pins required by the scanning technique to detect repressors. Like CLCD, which is nothing but character liquid crystal display, which is mainly used in which is mainly uses the embedded system to show the text-based information. If you like, we can say example like you are messaging to your friend by using a text like hi or hello, good morning or good evening, anything, whatever. Like it can be used like a embedded system, which is nothing but a character liquid crystal display, which is short noted by that. And types which can be like 16:2 or 16:4, it's that have two types. And also, and the next topic is timers and interrupts. A timer is a microcontroller in a hardware module that counts clock pulses to measure time intervals or generate precise delays. It can be operated in different modes in any delay generation, event counting. An interrupt in a microcontroller is a signal that can be execute a specific task, then task can be like then can be able to resume normal execution. It enables real-time response to external or internal events like sensor inputs, time overflows, or communication signals. Prescaler and postcaler, they are the types of the interrupts. You can see once the TMO 2 bits is enabled, it start up to like 250, and the time period can be measured by like 1 second for the 250 tick up to, and also complete one cycle it takes about along through like 1 second or 100 milliseconds. Basically in this project we can be requirement of like CLCD, which is obviously used for inputting like showing the text of in the device, and also matrix keypad is used for in giving input, and also buzzer and fan. These all are the things we have seen, like going to see about the project so in a overview manner. Let's I'm asking my friend Siddharth like to explain about the project implementation. Thank you.
Here, as you can observe, there are two windows. On the left side, we have a MPLAB X IDE, which is a IDE we use to program the microcontroller. The IDE uses XC8 compiler for cross compilation of this program for our microcontroller device. On the right side, you can see a window which uses a MPLAB simulator, simulator, which is a simulator which uses a microcontroller development board, including PIC16F877A microcontroller. Now, using this both, we will move forward how the program works. First, as you can see, we have a void function for initialization and configuration, which includes the CLCD initialization, the matrix keypad initialization, and the timer initialization. We also have uh, other macros defined, such as buzzer DDR, buzzer equal to off, and fan related macros which set the initial configurations. In the main program, we have a init config called at the start, which initializes the hardware components and sets the initial configuration. We have a power on screen function, which is nothing but a simple function which occurs at the start of the program. Power on screen here, as you can see, just displays power on and microwave oven as a display. We can see that when we reload the X file, we see a power on display. Now, moving further, we have uh, operation mode. Operation mode is a variable used to set a macro. These macros are related to the various operation modes. For default, we have cooking mode display, which is the display here shown at the right side. Cooking mode display just calls a function called cooking mode. Here, the cooking mode display function, as you can see, displays the four cooking options. Now, moving forward, we have a while loop which takes in a key input. This key input is used in a if-else ladder to select the operation mode. Depending on the key input, we select the operation mode. For example, for key equal to 1, we set key operation mode as micro mode. For key equal to 2, we set operation mode as grill mode, and further. Next, At the end of this if else ladder, we have an operation call which takes key as a in- input parameter. This operation call then goes over the switch cases, which switches the case depending on the operation mode. We'll further discuss now the four operation modes and see how these operation modes work. As you can see, the default operation mode is the cooking mode display. If we select the micro mode, we select it by pressing a key equal to 1. Then it goes to a function called set time. The set time function is used to set the time. As here you can see, this is the set time function. Here we set a small time for 10 seconds. We can set a further time which includes the minute as well. So when we press the hash key, for example here, if we press the hash key, the timer is set to 1. That means the timer is set to on. The fan is on. That means that indicates the on operation of the microwave oven. And the operation mode is set to time display. Now we set the hash key to verify this. Yes, the timer is on and the setting goes to timer display. Now, when the mode is on timer display, function called time display is called, where we have four other options as shown here. Next, we'll see the grill mode, which is similar to the first mode. Here again we get a same call for setting the time, and we press hash key and we get this set time display function which sets the time, and when the time minutes equal to 0, second equal to 0, the timer is off and cooking time is up. We clear the display and we set the operation mode again to cooking mode display as shown here. Next we have convection mode. For convection mode, we have a set temperature function which works at the start. The set temperature function, if we set a temperature more than 250, we get a warning saying the temperature is greater than 250 and it's invalid temperature. So we'll verify this. Yes, it's an invalid temperature. So we set a smaller temperature, suppose 100, and we press enter. Now the mode enters into preheating. This is specific for the convection mode. Now in the preheating, we on the timer for 50 seconds and just count until it goes to 0, and then again we get a option to set the timer for the convection mode, which is similar to the first two options, that is the first two modes. Now we also have a check to just if check if the door is open. If the door is open, it will display open door. For every operation, it will check if the door status is closed. If the door status is closed, it will move forward. Now we are on the same screen where it says set the timing. we go to the last option, which is the start. Start option is just starts the timer. This can be used to just heat the food. For example, here if we press the start, we'll just start a timer with 30 seconds. We have a possibility to pause. That is, if we press 5, we have a possibility to pause the timer. We can resume the timer using the button 4. We can resume the timer, and using button 6, we can stop the timer. In the start, we also have option to increase the time by 30 seconds. If we press the start option, that is button 4, we increase the time by 30 seconds. If we double press the start, that is button 4, we increase the time by 1 minute. As you can see, the time has increased by 1 minute. Here you can press 6 to stop the timer. Now this was the entire working simulation of microwave oven. I would like to thank Imaxi Institute for Embedded System for conducting a very beautiful and meaningful internship program and clearing our fundamentals of embedded systems and microcontrollers. Thank you.